Hi everybody, welcome to Matrix Live, Season 6 I think, and I have no idea what episode it is, and I'm here with Neil. Hello Neil,
Hello.
how are you?
Not too bad. How are you doing?
I am surviving, slightly recovered from FOSDEM at the weekend, and I think that we shouldn't talk about FOSDEM at all. We should talk about completely new things. In fact, well actually, having said that, did you talk, I have to say that I haven't watched no, I actually did watch all of your peer-to-peer talk in the end. Although I did it at like 2.5x speed on YouTube because I didn't have much time. But very sped up. It was very good. But I also can't remember how much you talked about the next generation peer-to-peer stuff that we've been doing in it.
Yeah, so when I recorded the talk of, which was probably about a month ago now, that was really just when we had the demo working on iOS. It was still a little bit scratchy. We had nothing on any other platform at that point, or no other mobile platform anyway. So it's nice to have graduated beyond that. We now have a demo that works on Android as well, with well some mixed success anyway. So yeah, I'll be able to show you that today.
Cool. So this is using Pinecone. I guess this is actually, other than Fosden, Pinecone's first actual proper debut, because we've been annoying people by kind of teasing about it on Twitter and Mastodon, etc., but never really said what it is. So perhaps we should do a sort of recap of where the peer-to-peer stuff is quickly in general on Matrix right now, and how Pinecone fits in with it.
Yeah, so there's actually Pinecone has had a little bit of a secret debut anyway, because the last couple of test flight builds for the iOS demo have secretly been using it, and I just didn't tell anybody. But Pinecone is basically an attempt to build a routing scheme that's very much like Yggdrasil is. It builds a global spanning tree, and nodes are routed based on their position on the spanning tree. But Pinecone adds an extra layer to this, which is that it adds source routing. So where Pinecone has a benefit over Yggdrasil at the moment is that if the coordinates of the tree change because some parent node on the network somewhere disappears, you shouldn't lose all of your connectivity over Pinecone, whereas you probably would with Yggdrasil. And at the moment, that's pretty much the main difference. It is a protocol break from Yggdrasil. It's a totally clean room design, but that's the main thing that sets it apart from the Yggdrasil demos before it.
And it's a new code base as well.
Entirely new code base, yes. It's written in Go as well, just because it was very easy to hook it into Dendrite that way, and it's very simple to build it for iOS and for Android.
And it's still using Dendrite as the home server, running inside the app as just native code, I guess, on iOS and Android.
Yes, so we use a tool called Go Mobile, which builds basically whatever you tell it to as either an iOS.framework or an Android.AR library. So we can just take those and drop them straight into Element iOS or Element Android, and it's all native.
Very, very cool. So shall we try to play with it and do a live demo? What can possibly go wrong?
Yeah, what could possibly go wrong?
So I guess I've got the iOS peer-to-peer app here in with Pinecone running on it. I guess you do too. Do you want to screen share and?
Yes. So I'll just share my screen.
Oh, there I am. Hello world.
So you should see my iPhone in the middle and an Android device on the right. And you will notice, first of all, on the right-hand side, that the Android device has got no connectivity. It doesn't have a SIM card. It doesn't have Wi-Fi because it's switched off. So just to bear that in mind.
And to confirm,
But
this is some screen shares from like Visor or something rather than emulator. So this is a
yes,
real
so this
physical
is
Google Pixel or something.
it's a real physical Google Pixel 4a, which I'm holding in my hand at the moment.
Very cool. And
So on the
on my
iPhone in the
side, I
middle,
should say that I've also got the iPhone app sitting here.
yeah. So in the bit in the middle, that's the room that here's one we made earlier. So that should be exactly the same as what you see on your device. If I send a message,
Ooh, Neil iPhone is typing. Hello, hello. When I'm back, I can say from here. There we go. It's amazing. Okay, so this is
and
going over Pinecone over the internet, just from our normal iPhones.
yeah. So what I will do is I will open up the P2P demo on the Android device and hope this works. We'll press get started
Ooh,
and the Android
BLE
develop.
advertised started. So what hang on a sec. What is BLE?
So BLE is Bluetooth Low Energy. This is the protocol that a lot of smart devices use. So if you have something like a smartwatch, you probably are using BLE. A lot of things like, like kitchen scales that are Bluetooth enabled and toothbrushes and all these wild things that now talk Bluetooth, they tend to be using Bluetooth Low Energy. And the idea is that it's a much more power efficient protocol than classic Bluetooth. It's also lower data rates, but you should be able to build something using BLE that can run on a battery, a little accessory that can run on a battery for maybe a year at a time. iOS and Android both have support for this. And the main benefit to us here is that BLE works in many cases without pairing devices. So whereas with classic Bluetooth, you quite often have to pair the device, it shows 6-digit code, check it's the same on both devices, and that's the only thing that lets the two devices talk. We don't have that restriction in the same way with BLE. So what we did is we wired in BLE into the iOS and to the Android demos. And on the right-hand side now, the Android device, you should notice a little icon at the top that shows the P2P demo running. It says one nearby device, which means that it's probably found the iPhone. The iPhone reports one connection, which is the fact that I've spoken to Matthew over the internet, but via two devices. So one of those devices is the internet peer, and the other one is the Android phone. So if I now go into the room directory on the Android device, with any luck, yeah, there we go. It's found the room, so we'll join that.
Oh, Android just joined on my side. Haha, it's working.
So now I should be able to go into room list and say hi. So typing on the iPhone.
Yep.
If you hold up your phone, hopefully it's arrived.
Not quite yet.
Not quite yet.
Let me go into chuck something in on my side. So, yeah, interesting. So I haven't got it coming through yet to mine. So why would that be? I can see you typing. And I've got your emoji coming in there.
I don't know, to be honest. It's most likely either that it hasn't found a route through the network yet, or Dendrite is doing something strange, which wouldn't surprise me.
Let me just cancel my notifications. Ramondine's asking me if I'm currently doing Matrix Live.
So we do see two active connections on the Android device. So if we try this again.
Oh, I just got the. Sorry, it did come through. I got distracted by Amandine, but you can see the Android.
Yes, it's come through now.
Yeah, try this again. So we're fine. Nothing to worry about. Although, what would have been going wrong to cause that?
One of two things would have either been going wrong. One would have been that we've just failed to find your device on the network at that point. There are still some bugs in the DHT implementation in Pinecone, so that's one quite likely explanation. The other is Dendrite. So we do have occasional problems with Dendrite still, even in production, and we see it on dendrite.matrix.org, where if you get some events and you haven't got the room state, it sometimes takes us quite a long time to reconcile that. And once it's done it, it's fine.
I love the fact that my Memoji manages to make it through to Android, but there we go. The thumbnail wasn't coming up on iOS. That's pretty cool, though. Is that our first ever file transfer, actually, over Bluetooth Low Energy?
I mean, I've tried it with stickers and things on Android, but I've never sent anything bigger than that, and I've certainly never sent it over an internet peer. So that's the first.
Words of truth. Do we know why the thumbnails aren't coming up on iOS? Is it just
I have no idea. It happens sometimes. I don't know if it's to do with the file type, but also the iOS demo is based on a slightly older version of Element iOS.
Oh, right.
So it's possible that it's been fixed on the normal client, and I just haven't merged in those changes yet. It's thinking about that. Oh, I don't think it wants to send that. Have a look at it.
Nah, so close. It's clearly being slothful.
Yeah, so one thing to be aware of with Bluetooth Low Energy is that the data rates are a lot lower. So I think in practice, we probably get somewhere between, well, on paper, it should be 1 megabit per second, but that's not including all the overheads and the fact that that varies a lot based on signal strength. I think in practice, we'll probably get between 0.1 and 0.3 megabits per second. So it's ample to send text and to transfer a little bit of room state, but I don't know that you're going to be sending massive chunks of data over it anytime soon.
Something else looks like it's gone wrong here, though, right?
Yeah, this doesn't look like it's attached the stuff. I don't know if that's a problem with.
It's still mentioned to receive my messages.
Yeah.
Okay, perhaps what happens if we... well, first of all, how do we get it out of that stuck state?
Good question. You can try killing the app.
That's probably best. I was going to suggest we could try... In fact, are you sharing your iPhone over Wi-Fi there? Or are you on a physical USB-C?
It's wired in with USB.
Cool. Should we kill the network on the iPhone and see whether, and to prove that it's really working completely Bluetooth?
Yeah, so if I go back into the demo here, and you'll see that it says 1 nearby device, 2 active connections. So if I kill that now, it should show, yeah, no connectivity. If I go back into the demo.
Oh, but you need to kill your Wi-Fi, right?
So Wi-Fi isn't enabled
I guess it's good
on the Android.
Yeah, okay, but I was just
If I
thinking
turn-
for pure dramaticness, the idea that both phones have no actual wide area network stuff at all. But
If I try turning Bluetooth off, it might take it a few seconds to notice.
oh yeah, that's a good idea.
At the moment, it still shows 1 nearby device.
So where did you turn off Bluetooth? Oh, on the Android side.
Just on the Android, yeah.
Well, as we said, it's not exactly robust to resilience and recovery yet.
Yeah, and what I'm not sure about is how long it takes the Android SDK to tell us that an L2 cap session has actually died if Bluetooth disappears. There's still quite a lot of work to do on making sure that we actually recover from failures properly with this. At the moment, it's a little bit hit and miss.
So what is L2 cap?
L2 cap is it's one of the fundamental building blocks of Bluetooth connections. So it's basically a streaming carrier. The idea being that because your maximum transmission unit size on Bluetooth tends to be a lot lower, L2 cap takes all of that away, does all of your fragmentation, makes sure that things arrive in order, and pretty much gives us the semantics that we need for pinecone connections between devices.
And what sort of MTU do you get over this?
Really, anywhere between, I think the lowest specified MTU is 23 bytes.
Wow.
And I think the absolute maximum that it can go up to is 512. iOS will try to negotiate 512 bytes on pretty much any device that supports it. On Android, it entirely depends on the manufacturer, really.
Makes sense. I'd love to know what factors go into it. And I was actually listening to Bob Metcalf talk about the creation of Ethernet the other day, and he was explaining where the 2.94 megabits per second of original Ethernet came from, and it was basically dictated by the type of capacitors that they could buy at the time in terms of the number of picofarads available. Right.
So what I've done there is I've turned Bluetooth off on the Android, and I've killed the demo on both devices just to make sure that it really is noticed this time. So you'll see that it's got no connectivity on the right-hand side. Mm-hmm. The iOS device still shows one device because that's got the internet peering. If I turn Bluetooth back on, with any luck, this will either notice or I might have to kill the app again. I'm not sure if it will pick it up straight away.
This is entirely my fault for pushing you to go completely off script and test all of the recovery mechanisms for the Bluetooth coming and going.
Yeah, I mean, this is the thing that at the moment, most of the Bluetooth setup is done when the app is opened. Mm-hmm. So it makes the assumption that Bluetooth is available when the app starts. That's probably something that we can fix fairly easily. Yeah, so having reopened the app, it's now found the nearby device over Bluetooth again.
Cool.
It's just I haven't had the opportunity to go through and do all that yet.
Cool. And is it going to recover in terms of the DAG?
So if we now try sending...
It's still stuck with its bloody sloth.
Yeah, that might be stuck permanently now. I don't know if there's a way to cancel transfers on... Yeah, we can press cancel there.
Oh, there we go.
It should hopefully recover. It does take a little bit of time again when there's gaps. It can sometimes take a little bit of time to reconcile that, but that's more of a dendrite problem than than a Bluetooth problem.
No, I'm still out there, able to talk to you on my iPhone. What about, can we get... No, are you scrolled up on Android? Is that what's going on, perhaps? No.
No, I think it's maybe just a little bit slow.
Well, there we go. I mean, at least it gives people an idea of where things are at right now on it. And so what are we going to do about store and forward and sort of reliability of the DAG? In fact, should we stop screen sharing so it's not just me being low frame rate? There we go.
So that's a really good question. Store and forward is something that would help us to deal with the fact that devices can disappear and reappear at pretty much any time. And especially not so much with Android, where background services can run for much longer, but on iOS, if you just swipe away the app and leave it in the background, it probably has about 2 or 3 minutes to live, and that's about it. So what we would probably look to do then is to send messages through the network to somewhere that is topologically quite close to where the device was, or quite close to the device's public key, and say, right, here's a message. It's valid for, say 6 hours, 12 hours a day. If you see the device come back online, forward it on. The problem that we have there is how to deal with recovering state if all of the devices that were in the room are no longer online. So that's something that we need to think about. But at the moment, the demo very much relies on the devices that are in the room are available at once.
But could we just dump all of the events and index them by the hash, like the ID of the events, and have the store and forward as just some distributed, well, literally a distributed hash table almost, where you might be able to pull out these events. You don't know where they are or who they are. Hopefully they're end-to-end encrypted, or we at least we obfuscate them enough so we can't see the metadata. And yeah, in fact, isn't it good enough to have the hash going to some mangled version of the body of the event, so you wouldn't even know who it was from or to?
Well, what we could potentially do, going back to putting events into a DHT, we could potentially do that, which is that if you know the event IDs, you could go and ask the distributed hash table, right, find me any device that knows about this event. Or you could probably do the same with room IDs if they were based on a hash, or anything basically like that, user IDs if they were based on public keys. And then you could go out into the network and say, right, find me any device that's got these. And then you at least have somewhere that you can go and ask to say, right, I'm looking for this. I'm looking for this room. I'm looking for this event. I'm looking for this user. You're the only person that's left in the world that seems to be online and can tell us about it. The problem there is, and this is a similar problem to things like that IPFS face, is that it's all very well putting all of this stuff into a DHT and telling people that it's globally available, but it's only as available as the data has been requested, if you see what I mean. So if you've got 4 devices, 2 of them are in a room, only 2 of those devices are probably going to have ever known about those events to pull them and cache them locally. The other 2 devices are likely to be blissfully ignorant of them because it's just never come across their radar. So it still doesn't really solve the problem when you've just got a couple of devices, because it's it's a direct message, or it's a very small room. In bigger rooms, it would certainly help to be able to do that. And that's something that we can look at.
Presumably we could also gossip the events gratuitously, like gratuitous ARP effectively, and go and smash the... if the events are completely encrypted so you can't even see the metadata, does it matter that much if the DM style conversation gets shared with other random peers that you're aware of?
Yep, so gossiping is another thing we want to look at as a means of improving the federation protocol, because again, at the moment, this is very much based on how Matrix works today. So it's full mesh. If you're in a room with 3 other devices, you send one message, it has to be sent to, you have to duplicate the message for every other device. And we've seen that just demonstrating the demo there, that you can type a message in and one device will receive it a damn sight quicker than the other one will. Gossiping is about finding a way to work out what the minimum topology is over the network for devices that are in a specific room, and only duplicating events or room traffic the minimum amount of times we need to in order to make sure that everybody hears it. In that case, any other devices that were on the path of gossiped traffic could just take a copy of those events and store them, cache them at least for, maybe a couple of days or until a certain storage boundary has been hit. So that might help. But we go back to the problem that you don't necessarily know whether those devices are going to stay online any longer than anything in the room. So it's, this is an open area of research, really. We need to try it and see what happens. And then we need to go out walk some devices around and change the topology and take some of them offline, bring some of them back, and see what we can actually do in those conditions.
Oh, it's super exciting to see the cross-platform BLE stuff working, and I guess with a bit more work on the resilience, the next obvious thing is probably going to be the store and forward conundrum.
Yes, so we probably need to fix some bugs in the routing algorithm in Pinecone. We need to have a look at store and forward and gossiping. Those are the main things on the roadmap.
And also account portability, I guess. Although I'm assuming that right now we just are happy with each device being its own account, and then the whole account and portability is a whole another level of complexity to add on later.
Yeah, so the account portability is a bit more of a matrix problem than a peer-to-peer problem. For the sake of just testing, yes, we can just assume that each device is its own account.
Cool.
The account portability piece is going to be especially important when it comes to mixing peer-to-peer devices with fixed home servers and people's existing accounts.
So when can we play with this, by the way?
The demo as it is today?
Yeah.
That's available on iOS on TestFlight already. And we do have a Firebase app distribution link for the Android demo as well. I'm pretty sure both of those links have been pasted into the hash P2P on matrix.org channel.
Okay.
If not, I can drop those into the topic so that you can easily find them. But in theory, if you've got a fairly recent iPhone or you've got an Android device that's running Android 10 or later, you can try it today.
Awesome. And in terms of the source being available, I guess we're still playing with it and tidying it up first.
Yes. So the plan is to fix a couple of bugs, get the source code tidied up for Pinecone, get that released. And the same really for the iOS and the Android element forks.
Cool. Well, thank you, Noah, for giving us a VIP tour of all the latest crazy Bluetooth low energy stuff. And the demo almost worked perfectly, at least the important bits worked well. Sorry for pushing it off-piste. And congratulations on getting the BLE stuff working. It is going to be an exciting shape of things to come.
Yes.
Cool. Well, speak to you soon. Thanks.
Thanks very much.